into a glass.
Yeah.
Making a toast.
Yes. All right, here's another one.
Thunderstorm.
Yes.
Chalkboard. Writing notes on chalkboard.
Yes.
Opening and Coke.
Yes. Okay. Y'all can turn around. So in the last one, or top can opening, that's carbon dioxide escaping from soda. So today we're going to talk a little bit about carbon dioxide and its roles in the environment and in turn agriculture. Okay, so this is just an outline of what's going to be done, what we're going to be going over today. Like I said, learn about carbon dioxide and its function. We're actually going to simulate a reaction that yields carbon dioxide, kind of like they did with the yeast. And then we're going to learn what major producers of CO2 is on Earth and what that means. So what is CO2? It's a colorless, odorless gas, and as the name implies, it's a carbon double bond with two oxygens. And so the function of CO2, basically, as a whole, its function is just it's a greenhouse gas in the environment, and it just stays in the atmosphere with a couple of others. Does anybody want to guess what some of the others are? What the 5 main ones are? Carbon dioxide is one. Methane? Methane.
Oxygen.
Close.
What?
Water vapor, methane, CFCs, and nitrous oxide. So you all were kind of right. Does anybody know what CFCs are? Out of curiosity.
Oh, Joanne just talked about this. Like the stuff that comes out of your refrigerator.
Yeah, chlorofluorocarbons. But yeah.
And hybrid.
So these are actually water vapor is actually like the one that makes up the most amount of greenhouse gases, and then CO2 is the next one. So what they do is they act as a blanket around the Earth. Y'all probably talked about this if you ever learned about global warming in high school. Basically what they do is they just absorb heat from the sun, and then they warm the Earth to like a life-supporting 60 degrees, because we can't live in too extreme cold or we can't live in too extreme hot. So it just acts as like a regulator of how much heat actually stays in our environment. And so this is just a diagram showing you how that happens. Light goes in, some of it stays in here, and some of it gets bounced back. And so we're going to simulate a reaction. Does anybody know, like off the top of their head, what's a classic example of a CO2 reaction? Yes, an explosion. Okay. Did you all ever make a volcano?
Can you put like Pop Rocks and Diet Coke?
Oh, Mentos.
Mentos, or yeah, something.
Mentos and a Coke.
Not the one I'm looking for, but yeah, that works too. Baking soda and vinegar. So like, if y'all ever made like a volcano in your science class or whatever, baking soda. And that just makes it start here, which then, we'll talk about that when we get to it. So what you all have here is a bottle and a balloon. So I want you all to go ahead and take the top, well, actually take your balloon off first. And it might be a struggle because I really want it to stay airtight. So, and now I can't even take it off. So
I know.
Hey, no one's got it. Don't tell me.
Okay. I'm struggling to get mine.
No, I don't know.
Not yet. I'm just saying. Okay.
Yeah, I'll open it.
So go ahead and take the top out. Okay, this is what you have, obviously. So what we're going to do is you're going to want to stretch this out a little bit, and then very carefully put it over the bottle, and then just leave it hanging there for just a second. Okay, so everybody's on there nice and snug. Okay, so really carefully, you're going to want to tip your balloon out and hold it.
Oh, God.
Okay, so all that stuff fizzing up, we're going to talk about in just a second. But as you can see, there's obviously a gas going up there. You can see it in the balloon. I'm glad everybody's worked, because I was trying to set up with my board, and it didn't work sometimes, so I'm really glad that it worked. So let's talk about this a little bit. So why reactions are going on here, an acid-base and the decomposition. So in your acid-base reaction, something's made, but it's not stable enough to stay that way. So it just turns into something completely different because it can't stay together. And basically, that's what it turns into, is CO2, because it can't stay together. And so as you can see now, but there's water in here now, and the vinegar's in there now with the water. And then your baking soda is basically almost gone because it was used up to make sodium acetate. And then here's all your CO2. And so how else can it be produced? There's a couple of them in this picture, but I just wanted to see out of curiosity if you all can guess what any of the other contributors to CO2